Hey everybody. So in this video we're going to look at something called a comparison operator because that's going to help us build logic statements in the in this lesson. So logic in computer programming is based on something called Boolean logic. Okay, so Boolean variables are variables that can take on a value of true or false. Okay, now that's really useful in programming because everything is based on binary code, which is a 0 or 1, or in a hardware state it would be an on or an off. Okay, so you can think about a true representing the value 1 in binary or representing an on state in the hardware, and then false being 0 or an off state. So if we can kind of combine all of those like decisions together, we can get a fairly complex structure programmed. Okay, so you can actually set the value of variables to true or false. So true and false is a keyword in Python, so you could say like x equals true. Okay. Notice that there's a capital on it there, so if you wrote it this way, it would not know what you're talking about. It would just think that is a variable called true, and it wouldn't know what it represented. Okay. So true or false variables will have capital letters on them, so you could say y equals false or something like that. Okay. And the point is that we would probably not do something like this too often, but we would usually want expressions to evaluate to true or false, because if we can do that, then we can say if something evaluates to true, we can do something with that information, or if something evaluates to false, we just choose not to do something with that information. And that's going to be in the next video where we talk about if statements. But we're going to concentrate here on creating true or false comparisons. So one of the things that you can do is you can compare variables together to see whether they are equal. Okay, so let's just set up a program where we've got two inputs from the user. Okay, so just integers. So say enter a number, and then we'll do the same thing for value b. Okay, so two numbers, both integers, both coming in from the keyboard. I can compare a to b. Right? And I can compare whether they're equal, not equal, greater than or equal, less than or equal to, just strictly greater than or less than. So I can compare all of these variables together, and that comparison would always generate a true or false answer. Okay? So if I were to say test for equality, I could test A equals to B. Right? So if I were to run this program and I enter 3 and I enter 3, that's going to tell me it's true because it's doing this comparison, 3 equals to 3, and that is true. Right? But if I ran the program with 3 and 4, it's going to tell me that it is false. Okay? So notice when you're doing a comparison with equality, you're using two equal signs. Right? That's to distinguish between like this type of equal sign, which is an assignment statement. So one equal sign is a sign, two equal signs means a test for equality. All right, and you can also test whether numbers are not equal to each other. Okay, so the not symbol that you would use, or not equals to, would be a exclamation mark and a equal sign. Okay, that's going to be our not equals comparison. So if I enter 3 and 3, that would generate false because 3 does not 3 equals 3 3 does not equal 3 would be false. Okay, that's a really odd way of saying it. This would make more sense, right? 4 does not equal to 3, that is true. Okay, and you could actually assign the results of these variables to, the results of these comparisons to variables themselves. They don't just need to be put in a print statement. So you could make some weird statement like this that said the comparison is equal to A not equal to B. Okay, so that looks really odd from a coding point of view, but you just have to remember that, right? the compiler is going to, or the interpreter is going to evaluate the right-hand side of this equation first, okay, and then it's going to assign that value to the variable comparison. So this will end up being a true or false value, and then it will assign it to that variable. So if I were to print its value, okay, so 4 and 3, it's going to print out true. Okay, so we can store true or false values in variables, and we can use them however we want later, and we will do something useful them in the next video. Okay, and you also have your greater than or less than symbols as well that you can use. So if you're looking at greater than, it would be, say, something like that. Greater than or equal to, it would be greater than and an equal to sign, and then your less than and your less than or equal to sign. Okay, so any one of those comparisons, you've got what, 4, 5, 6 main comparisons that you can make in a program that are going to generate true or false values. And you can only compare variables together. I mean, I suppose that you could compare this to a number, so you could put a number there as well. There is a way to compare strings together as well, and I guess we can kind of get into that when we start doing strings in a later lesson, like what it would mean if one string was greater than another string. But that's perhaps for a later time. And another thing we can actually do with comparisons is you can kind of create these like what we call compound comparisons. So making more than one comparison at a time or joining them together. So if you wanted, so there are usually 3 that we would talk about in Boolean logic. There's an AND comparison, an OR comparison, and a NOT comparison. Okay, so if you were to say combine comparison 1 and comparison 2, and means that if both comparison 1 and comparison 2 are true, then the entire compound comparison becomes true. Okay, or would mean if one or the other or both would evaluate to true, then the entire comparison is true, and not just reverses the value of a comparison. So how that would look in code might be something like this. Let's just get rid of that. So if you were to do, say, like if you had one comparison evaluate to true, right, and another comparison evaluate to false, then this should evaluate to false. Right, because not both of the comparisons are true. Right, so that might be something like if you had 3 equals 3 and 4 equals 3 or something like, 4 equals 3 or something like that. This is going to evaluate to true. This is going to evaluate to false. Right, so you would end up getting true and false, which would give you a false. Now, in the notes that you already read over, you had a table, right, that kind of talked about what happened or when you have different values for comparisons. So let's say we have comparisons A and B. Okay. And A or B could be true or false. Right. So if A was true, B was true, and then it's A is true, B is false, A is false, B is true, or they're both false. Okay. Then if you did A and B, then the logic says of this AND statement that only when both of these are true will this entire comparison be true. So this would be that one would be true, this one would be false because one of them is false, this one's false because one of them is false, and this one's false because both of them are false. Okay, so only when both are true would those actually evaluate to true in that compound comparison. Now there's also an OR. Okay, so if you did A or B, then as long as one of the comparisons is true, then the entire compound comparison becomes true. So with the first one of them is true. Okay, they're both true, but one of them is true. So that's going to be a true. Since A is true here, that's going to be a true. Since B is true here, that'll be a true, and this one would be a false because there isn't a true statement for that. Now there is another OR. It's called exclusive OR that would exclude the both being true. So only if one or the other, not both. Okay, but you don't really need to know that for this course, but you will need this one. Okay, and then there's the not comparison. So if you just had, you don't need all of them for this one. So if you had A as being true or false, then not A, right, would just be the opposite. So if something was true, then it would be, if not A would be false. And if something was false, then not A would be true. So this gives you a way to reverse a comparison if that's the logic that you just needed to have in your program itself. Okay, so you can create a whole bunch of these compound comparisons based on those other more straightforward comparisons to create a more complicated logic question that you could use, right? And it's basically like building an equation, right? There's also like a precedence that the order takes, just like BEDMAS, right? So the simple comparisons would always evaluate or precede the compound operators. Okay, so it would always do equals, not equals, greater than, less than, before it would then try to evaluate a and or not. Okay, and then those three compound comparisons have their own order of precedence. So not would precede and, right, and would precede or. Okay, it's kind of like multiplication or addition, and if you get into a lot of Boolean logic, you actually end up writing them like that with multiplication signs and addition signs, and they mean and or. So not evaluates before and evaluates before or. Okay, and we can kind of do an example of that in code as well. So maybe I have a statement like this. Okay, I'm going to need a number from the keyboard. So and let's make just an integer. Okay, and let's just look at how we would say evaluate this type of comparison here. So say x is greater than or equal to 3 and x is less than or equal to 10. Okay. You don't need the spaces there, but I just makes it look nicer sometimes. Now, let's say that the value of x is 4. Okay, and let's see what we think the value of this would actually come out to. Right. So as your program executes, what's going to happen is, okay, x is 4. I'm entering it from the keyboard. So I'm getting to this comparison. I'm replacing x with a 4. Okay. So now order of precedence says that the simple comparisons would go first, right? So that means this has to evaluate first, and then this would have to evaluate second. Okay, so 4 bigger than or equal to 3 would be true. Okay, and 4 less than or equal to 10 would also be true. Okay, so now we have a true, and according to the table that we've just been discussed, right, true and true would evaluate to true. Right, so this whole thing should print out true if I had x equals to 4, which it does. Okay. Now if I had, say, x equals to, let's say 12, right, then I would have 12 bigger than or equal to 3, 12 less than or equal to 10. So this would evaluate to true, and this would evaluate to false. All right, so now true and false, that would give me a value of false because they both have to be true in order to make this work. So put that back, run that code down here, and what did I say, 12? Okay, it's going to give me an output of 12, or sorry, an output of false for this particular problem. So if you take a kind of look at what this might do, this is a fairly common kind of compound comparison that you might use. This is actually checking whether x is between 3 and 10. Okay, and that's something you might actually want to do, right? Check if something is between two values, right? So you would use an AND statement in this case in order to create that logic in your code. And maybe one more example to show kind of how that would work. Let's say I have this situation here. I've got 3 values of variables, and I've got this kind of weird complex comparison statement, and I want to know whether that's true or false. So my program would execute it, starts filling in the values. So x is 3, y is 3, z is 1. Okay. So we go ahead and we do the simple comparisons first, because that's the order of precedence. So is 3 bigger than 5? Well, no, so that's a false. Is 3 equal to 3? That is a true. Okay. And now is a 1 greater than 2? Well, that is a false. Okay. So now we have false or true and not false. So now we need the order of precedent between the compound comparison, and not precedes and precedes or, so we do the not first. So not false means true. So this entire section here would become true. All right. And now we have false or true and true. So and goes before or, so we have to evaluate true and true first, and true is a true. Okay, and then finally we only have one now comparison left, false or true. Since one of these comparisons was true, then the entire thing would become true. So this piece of code should evaluate to true if we put it back. Oops. How we had it. Okay. And there we go, it does. And you could, I guess, play with the values of those if you wanted to try to see what values you would need to make x, y, or z to turn the kind of the output to false. Okay. So kind of the moral of this lesson is that we're going to be creating these comparisons in order to use them to make a decision, right? So in the next video, we're going to talk about if statements, and then we can say, so if a comparison is true, do one section of code, and if a comparison is false, we do a different section of code.